All right. Hello, everybody. So we're going to work on an example, and what we're going to use is a recipe. And so I was just baking a cake, and I found a recipe that said that I needed to bake the cake for 26 to 30 minutes. And I realized as I was baking this cake that this is actually a good example of a Gaussian model. So we're going to try to bake a cake here, and we'll put it on a nice platter. And we want to know how long to bake that cake. And you'll notice that it says that the cake needs to bake for 26 to 30 minutes. And we're going to assume that this is a Gaussian model and that range covers about 95% of the cases where someone would bake the cake. And there's lots of reasons that a cake could come out at different times. You know, there's different ovens have different temperatures. The temperature, the ambient temperature in the air, the way the ingredients were mixed. There's lots of different reasons, but we're going to assume that 95% of the time the cake comes out in 26 to 30 minutes and it's ready to go. So the first thing we want to do is figure out our best guess of how long it's going to take for this cake to bake. And this is pretty straightforward. If you had to take a guess, you would probably take the number 28, which is correct. So the 28, since the distribution is symmetrical around 26 to 30, then the middle point of that is going to be the value with the highest probability. The midpoint of that is 28 minutes. Remember that we use the symbol y bar when we're talking about the average. So the average, our best guess of how long this cake is going to take to bake is 28 minutes. But we also want to be able to figure out the standard deviation because that's going to help us understand what the distribution is. And so for that case, what we're going to do is we're going to draw out what a normal distribution, a Gaussian distribution would look like. Remember, those two things are the same thing. So we're going to draw it. Doesn't need to be perfect. And we're going to put our mean here at 28 minutes. And we're going to say that 95% of this distribution falls between 26 minutes and 30 minutes. And so what we want to do is figure out what value we need to look up to figure out how to make it so that 95% of the values that our cake could bake for fall in this area here. So we'll make the green the area that we want to look at. And so between these 2 points, 26 to 30 minutes, we want 95% of the distribution. That leaves 5% of the distribution left. And you can see that it's split between two tails. So the first tail is this left tail over here. And so from negative infinity to 26 minutes is 2.5% of the values. And then over here, from 30 minutes to positive infinity is 2.5% of the values. So what this says is that in order to figure out the standard deviation, we want to know how many standard deviations are between 26 and 28 minutes. And we know that the probability of having a cake that cooks less than 26 minutes is 2.5%. So what we could do is look up on a z-score table, or we could use R. And what we're going to use on R is the Q norm function. So we're going to type in Q norm, and then in here we're going to put the probability that we want to look up. And so in this case, it's 2.5%. So we're going to write 0.025, and when we do that, we get negative 1.96 standard deviations. And if we did the same thing over here for 30 minutes, we would find the same thing. So this would be the area of this pink part, which is 2.5%, plus this green part, which is 95%. So the total then is 0.975, so it's 97.5%. We'll also take Q norm of that, and that will give us 1.96 standard deviations. Now what we need to do is figure out how many, so we know 1.96 standard deviations from here to here, and so we can take the difference between these two. So we take 26 minus 28 minutes. So this is our y star, our critical value, minus y bar, which is our best guess of the mean. And then we're going to divide that into units of standard deviations. And our standard deviation, and then we know that in this case that equals negative 0.196. So we have negative 1.96 equals negative 2 minutes over a standard deviation. If we multiply this, we get negative 1.96 standard deviations equals negative 2 minutes. We'll divide by negative 1.96. And so we end up with a standard deviation that is approximately 1 minute. And if you did the same over here for 1.96, you'll get the same value. And so that means that we can represent this model. So our baking time can be represented with the model y bar equals 28 minutes, and the standard deviation equals 1 minute, assuming a normal distribution. So if we want to make sure that we are showing that we're assuming a normal distribution, we can say that y bar is distributed, that y is distributed with a normal distribution with a mean of 28 and a standard deviation of 1. I hope that helps you understand the basics of using the Gaussian distribution.